Hey there and welcome to Workshop 2 for 161324 data mining. So today we're going to be looking at pivoting dataset. So that's taking a dataset that is too wide and making it longer, or taking a dataset that is too long and making it wider. We're looking at joining two datasets together with the Liftjoin operator. We're looking at doing some tidying and also some data visualization, in particular looking at small multiples. So the first code block here is just reading in our data. So we can see that we're going to have the same data from last time, the roles data set, but we're also going to have an additional one, which is schools, and we're going to create that clean data set that we did last time. Notice there's a new package here, readxl, for reading data in from a spreadsheet. So if you haven't got that package installed, you'll need to install it first. And of course, Studio will normally prompt you with a yellow bar when you first load the Markdown file up. Right, so I'm just going to load that now. Okay, and here's our clean school role data. Okay, right. So the first thing we're going to look at is looking at pivot wider to turn tidy data into wide data. So up until now, this spreadsheet here is tidy in that every row is an observation, right? It's the observation of the count of students at a particular school, gender, ethnic group, and level breakdown. But this can make it great for a computer. So it's great for doing plots, it's great for summarizing data, for doing everything that we did last time with this data set. It's perfect for that. But it's not really all that useful for people to look at, because we have to compare the count of students across rows. And say we were comparing the total number of male and female students across ethnic group, for example, then what we could do is we could summarize the data easily enough to get the sum of students by gender and ethnic group. But then again, we'd have a row for European female, a row for European male, a row for Asian female, a row for Asian male, and so on, right? And so we'd have to compare those counts down the rows, and we'd have to take care of which row is which when we're doing our comparisons, right? Because we'd want to compare within ethnic group or perhaps within gender. So it might make better sense in that case to actually have the counts of the number of male and female as separate columns. Okay, now that wouldn't be good for plotting because we wouldn't have a single column for our counts. Instead, we'd have two, one for male and one for female, which would be a pain. But it would be good for looking at in a table. Okay, so that's what we're going to look at now. All right, so for example, here's some the ethnicity by gender table that I was just discussing. Okay, and you can see that this is hard for us to sort of read. What we notice is that there's more male students than female students in the Asians, in the European, in the international Philippine, in the Māori, and in the other. So it's across the board. So we can sort of figure that out. But it would be much easier if we just had two columns, one for females and one for males. Okay, and we can do that by pivoting wider. Okay, so pivot wider takes long data, so that's data where we have more rows than we want to end up with, right? In this case, we just want to end up with 5 rows, right? One for each ethnic group, and an extra column. Well, actually, it'd be the same number of columns. So we're going to take these two columns and basically sort of pivot them around a bit. And so pivot wider does that. Okay, so pivot wider takes in two values primarily. It takes in a names from column, which is the column from which you want your new column names to come from. So in this case, we're going to want to end up with a column for females and a column for males. So that comes from the gender column. And then we need to tell it where the values come from. So where are the values coming from that fill up those new columns that we're creating? And that, of course, is the students column. So when we run this code, we'll get our nice table. Okay. So this is, again, perfect for us to read as people, right? We get 6 rows, and we can easily compare across. But it's not going to be useful for graphing, for charting and things like that, because now we have 2 columns that we have to put on the y-axis, which is a bit of a pain. It is achievable, depending on what type of plot you want, but it is not simple. For example, it would be very difficult to get a stacked bar chart out of these graphics. In fact, essentially impossible with ggplot. You could probably do a side-by-side one with a bit of fudging about. Okay, so let's have a go. Let's create a column, a table with the total number of male and female students in each year level. So this is really similar to this one, except instead of ethnic group for the rows, we're going to have the year level. So we can do the same code, right? So let's grab that same code that we had before. Right, we're going to take our clean data set, and instead of grouping by ethnic group and gender, we're going to group by level and gender. Right, so that'll give us the table that we want, and then we're going to pivot wider. And our names from, again, is going to be our gender column, and our values from will be our students column. Right, so we get that data set there. And you can see that same pattern that we saw last time, where males are bigger than females in all of the earlier years, but in the later years, year 12 and year 13, it switches around. Okay, so males tend to leave school earlier than females, or at least some males leave school earlier than females. Right. Ethnic group by each year level. Again, this is going to be really similar construction, right? The only thing we really have to choose here is what do we want for columns and what do we want for rows. Here I'm going to choose Alright, so I'm just going to run that bit. So here we go, here's our year level and ethnic group, and I'm going to choose the ethnic group as the columns. So when I do my pivot wider, I'm going to go from ethnic group, and so we'll have a column per ethnic group. Okay, so we can see how things are changing. So this is particularly interesting, right? We've got more Asian kids at year level 1, 2 and 3, whereas we've got more European kids later on. Okay, so this just reflects the changing demographics in New Zealand in general. Okay, as obviously there's a lot of people like to come to New Zealand to live, which is fantastic because it makes New Zealand a more diverse place, and as a consequence, obviously the age structure of the population will be changing. So, for example, the age structure of the Māori population tends to be a lot younger than other populations. Same with the Pacific population; they tend to be younger. Okay, right. What about another one? Add a total column to the ethnic group by gender tables. Right. So we're taking this table here and we want a total column. Right. So there's a couple of ways we could do this. Let's grab all our code so that we can see the sort of the ways that we can do it. Right, so that there will create our data set. And then, so there's two ways we could do it. We could pivot wider first. So we could take our names from the gender column and our values from the students column. And then we could produce the total column just by mutate, right? Just by total equals female plus male. Easy peasy. Okay. Now this is fine in this case because it was a really simple thing. We just had to add together two columns. But imagine if we had to do that here. Right? Imagine we wanted another column here for total. What we'd need to do is we'd need to say the total is equal to the Asian plus the European plus the international fee paying, which is a bit of a hassle because it's got spaces in it, plus Māori plus other plus specific. It's a lot of typing, right? So the other way to do it is to compute the total first, because computing totals when the data are tidy is really easy, right? It's not so easy when they're not tidy. So do the summary on the data first and then do the pivot. Okay, so we could do the total afterwards, after pivoting, but this is okay in this case. But if we had lots of columns to add together would be tedious and error prone. We might miss one by mistake. Right. So alternatively, compute the total beforehand while the data are tidy. Okay, so we're going to do the same thing. But before we pivot wider, right, we notice that we're already grouped by ethnic group. Okay, so all we have to do is do a mutate, right? We don't want to summarize the data because we don't want to lose any rows, because we need all of the rows in order to pivot wider. So we're going to mutate, and we're going to do a total column. It's just going to be the sum of the students again. And because we are already grouped by ethnic group, that sum is done within the ethnic group. Okay, so essentially this is just the same as this, right, in terms of the number of rows used for that information. So when we pivot wider, that'll just be compressed down in exactly the same way, right? So then once we've got our done our tidying, done our tidy summary, we can pivot wider exactly the same way as we did before. So in general, this is a better method, right? Because it's less error prone, because we can guarantee that we're taking the sum across the correct things. We don't have to specify that we've got a male and female here, right? So this exact same code is going to work for all of these tables that we've done here. We just have to swap out the two things that we're summarizing over, right? So that's kind of nice. Okay, what about a table with the percentage of female and male students within each ethnic group? Okay. Right. Again, RStudio is doing weird things on my computer for some reason. So I'm just going to close that down, open it back up again, and we'll hopefully clean it up. That's better. My computer has been saying for about 3 months that it needs to restart, and I should probably get round to doing so. Okay. Try creating a table with the percentage of male and female students within each ethnic group. Right, so it's the same thing, but instead of the totals here, I'll notice here we've got this annoyance with the totals on the left. We could just switch them out, couldn't we? So we could just reorder things. In fact, there is actually a reorder command. Is it reorder? Let me have a look. No, that's not what we want. Is it rearrange? No. Is it relocate? Yes. So if we look at the help for relocate, to change column positions. Okay, so we want to relocate total column, and then we want to say after. Supplying neither will move columns to the left hand side. So what we want to do is after last column. There we go, look at that. It even has an example for us. There we go, and put the total on the end. Okay, so now we want to recreate this table, but instead of the counts, we want the percentages. Okay, or proportions perhaps. So what we're going to do is we're going to take that code. Now we don't want the total now, although perhaps we'll use it to get our answer maybe. So here is our table that we end up with our totals. So once we've got our total, we can create the percentage. Would be our students divided by our total times 100, right? Right, so there's our percentage. And notice that the percentage is computed within each category. Maybe we could round that with 1 decimal place. There we go. So our percentage is computed within each category, within each ethnic group. So now we don't need the students or the total column. We just need to pivot these two wider. So I'm going to drop those columns. So we're going to say select minus student minus total. Students. Perfect, and then we're going to pivot wider, and we're going to use the percentage instead. There we go. Okay. Right, so that's how to create tables. Now the next thing we're going to look at is small multiple plots. So that's where we essentially produce multiple charts at once. Okay, so last time in workshop 1 we produced a graph of the total number of students by year, level and gender. And so we should have got something like this. So you remember this plot here. Okay, so this is kind of what we were discussing earlier. We have this switch to females, more female than male in the later years. But what if we want the same plot for each ethnicity? So we want to break down this plot further so that it's not just broken down by gender and year level, but it's broken down by gender, year level and ethnicity. So the question is, do we see a similar pattern across the ethnic groups? We may not. Okay, I don't know. We're going to find out. So we could do this by filtering the data, right? So say we want to see whether this pattern holds for the European ethnic group and the Asian ethnic group, right? We could run this code here, right, which is taking our clean data set, it's filtering down to the European ethnic group, and then it's doing our group by level and gender and summarize total number of students and then plot them. Same as we did before, so if I run that, I'll get the same plot, but for, I'm going to run both lines of code, I'll get the same plot for European students, and we see the same thing. In fact, it's even more dramatic, the turnaround. And for Asian students, in fact, it's quite different, isn't it? Asian students, there are more males than females across the board. So we don't see this switching of roles in year 12 and year 13, although you do notice that the gap becomes a bit smaller. So the gap's a little bit wider from year 6 through to year 11, and then it drops off a bit. So obviously some Asian males in year 12 and 13 are leaving school a bit earlier compared to the Asian females in year 12 and 13. Okay. But of course we want to do this for all ethnicities at once and be able to put them all on the same chart so that we can compare them. Okay. And so we can do that essentially using this facet wrap command. So what we do is we compute the summaries that we need. So let me clean this code up so we can see what's happening. So we'll run that and have a look at that data set. Right, so we summarize across all of the variables we want. So we want the ethnic group, and within ethnic group we want the year levels, and within year levels we want the gender. Okay, so we're grouping by those 3 variables at once and summarizing the total number of students, right? And then we're plotting that, so we're plotting year level, total, filled by gender, so that's exactly the same as we had before, but now we're wrapping by ethnic group. And when we run that, we get our 6 plots all at once. Okay, so here's the European graph that we had before, here's the Asian graph that we had before, but now we get all of the others. Okay, this vars here helper function is acts similarly to the AES. So anything within the AES doesn't need to be quoted. So for example, we've got the level command. The level here is just a bare column name. It doesn't have any quotes around the edge like this. Right? We don't have that. Same thing. So the vars is just basically saying, look in the data set for this variable. Okay. Right. Now this is a little bit hard to compare, I guess, because of course it's set up the axes exactly the same way for all of the charts, which is generally what you want, right? In this case, though, we really just want to look at the distribution, and of course, because there are more European students than others, it's then hard to sort of see what's going on in the Pacific and in the Asian groups are a little bit harder to see, right? So we might actually want different scales here for the y-axis. Okay, and in fact that's what we are wanting to do here. So you can do that by looking at the helpful facet wrap. Right. So let's have a look at the helpful facet wrap. So I just put my mouse on it, put my cursor on it, press F1. Okay, here's the help here. Okay, so facet wrap, and we can see that it takes a scales argument here, and by default it's fixed. Should scales be fixed? Fix the default, free or free in one dimension, free x, free y. So we want the x-axis to be fixed, but we want the y-axis to be changed. So we want free y. Scales equals free y. right, will give us independent y-axes. Okay. And so now you can see that actually within the different ethnicities, there's quite a different shape. Okay. Okay, so instead of colouring by gender, produce separate plots by both gender and ethnicity by supplying both to facet wrap. All right, so we can do that. So we're going to take our same code that we did before. But this time, instead of filling by gender, we're going to take that out. And we're going to add gender as another variable to wrap by. Okay, and so you get a Asian female plot, an Asian male plot, a European female, European male, and so on and so forth. Right? So this is perhaps potentially a little bit harder to compare depending on what you're wanting to look at. If you're just wanting to look at the distribution, then this might actually be easier to look at. But if you're wanting to compare the distribution between male and female, then perhaps this might be easier because you can comparable bars are right next to each other, so you can see, for example, when things switch here. Okay, so it sort of depends on what you want to evaluate. Now, this plot isn't the best way to do this because it would be much better if we sort of had these on a grid, right? If we had, which I guess we could simulate by changing the number of columns. So if I change the number of columns to 6. Is that going to do what I want? Let's have a look. Not quite, because I've got female then male. I really need the columns to be the number of 2. Right. So this sort of does what I want. So I've got female down here, male down here, and then Asian, European, international fee. So I've got things sort of on a grid. I guess I could reverse the order of these, couldn't I? So if I reverse the order of these, and then switch the number of columns to 6, then it'll split by ethnic group going across first. So now here's all my female, here are all the males, and here are the different ethnic groups. So again, I could compare female to male within group by comparing down the column, and I can compare within females and males by comparing across the rows. Okay. Now this grid layout is taken care of us specifically by facet grid. Okay, so there's a lot of we're using female here all the way across and male here all the way across, which is a waste of space, right? So the other way to do this would be to use facet grid, which is specifically looking at making a grid. So it takes 2 variables, one for the rows and one for the columns. Columns must be cols. Okay, there we go. So that's a slightly cleaner version of this because it's taking these labels for the female and male and merge them and put them on the side because of course they do apply to the row across the board. Now notice that when I scaled the axis with free y, it only scaled the 2 rows independently. We don't have scales in the middle here, so the disadvantage of going with a grid is that everything in the same row has to be on the same scale. Okay, so that's the potential disadvantage of going with the grid. Notice the other way we could do this is that because the actual y-axis here doesn't actually matter, because we're looking at the distribution, what we could actually do is convert all of these to percentages within ethnic group and gender, right? So that then they're all on the same scale anyway. So that would be another way to do it. Okay. Right. Now we've got the schools data. So this is another data set which comes from the same source. And so this is basically all of the school level variables. So we've got 1 row per school now instead of 1 row per school, ethnic group, gender, level breakdown. But then we've got other information. So we've got the sector, composite, primary and secondary. We've got the type of school. So there's all lots of different type of schools. We've got what authority they're under. So are they a state school? Are they integrated? Are they private? There's lots of different variables under the authority. We've got the decile rating, which is basically it's a measure of the community around the school. So I don't think it's a measure of the children in the school. It's a measure of the community around the school, and essentially it's a measure of wealth, basically. So decile 1, I think, is very wealthy, and decile 10 is not very wealthy. I think that's how it works. We'll see later anyway. Then we've got the school gender, whether it's co-ed, whether it's male only or female only. We've got affiliation type. I can't remember what that is. Perhaps something to do with religion. I can't remember. We've got whether it's a kura school. So we've got the kura type. We've got the regional council. So Auckland, Otago, Waikato, and so on. We've got the territorial authority, which is a breakdown within regional council. So we've got within Otago you've got Dunedin and so on. Within Manawatu Whanganui you've got Whanganui and so on. And within Auckland this is actually broken down further. So I think this is ward or something like that within Auckland, because Auckland is massive as the territorial authority. And that's it. So we've got lots of other variables to play with here. And so we could do some summaries. So for example, how many schools are there in the Palmerston North Territorial Authority? Right, so we're looking on that variable there. So we take our schools data and we filter down to the Territorial Authority as Palmerston North. Right, there it is there. And then how many schools? 44. Easy. So we could just go count the number of rows, right? 44. Okay, of the schools in Palmerston North, how many are co-ed, single-sex schools, or single-sex boys? Right, so it even tells us the code we can use for that, which is handy. So let's take our Palmy schools, and then we can count the school gender. Okay, so we can see that there's only one single-sex boys school, one single-sex girls school, which is Palmerston North Boys High School, Palmerston North Girls High School, and the rest of co-ed. And produce a chart of the decile distribution of schools in Palmerston North in the primary sector. Right, so we want the same filter, but then we want the primary sector. So if we go back to our data and have a look back through our columns, we've got a sector column. So we want the sector equals primary. So there's our primary school, and we want a chart of the decile distribution of schools. So along here we've got the decile somewhere. Where's it gone? Oh, there it was. Missed it. Yeah, here's the decile. So we want to produce a chart for that. So we could use a column chart for that. We're going to have to put it into ggplot first, aren't we? And then add on geom col mapping equals AES x equals decile. Actually, instead of geom col, we want a bar chart, don't we? Because we don't have a summary, right? All we've got is repeated measures, so we want to count them first. So geom bar will do that for us automatically. There we go. So that's what the decile distribution looks like in Palmerston North. Okay, so there's 2 decile 1 schools and 4 decile 10 schools. Okay. So next, it would be useful to be able to join the 2 data sets that we have together so that we have data all the way down to the counts of students by school, by gender, by ethnic group, by a year level, but we also have those school level variables that we can summarize over. Okay, so we join data sets with the join commands, and the key one that we're going to use in this course is Liftjoin. So there's 6 of them all up. There's left join, right join, semi join, full join, anti join, and inner join. So if you've ever done some SQL or SQL, right, where you've done filtering on a database, those things will probably be familiar to you. All of those joins are often used in joining two database tables together. Okay, left join tends to be the most common, because what you tend to do is you start with variables. You start with the rows that you want to end up with, essentially, and you're basically adding in other things from other tables. So here we're starting with our clean data set, which has our 108,000 rows or whatever it is, and we're going to be adding in those extra columns that come from our school data. And of course those extra columns are going to be replicated, or the rows in those columns will be replicated, because of course the schools data set just has one row per school, whereas the clean data set has multiple rows per school. Okay, so let's have a look and see what happens. So we get our data set that we had before, which is the first 5 columns here, but now we've got this extra information for the schools. So you can see that this is all just replicated because it's all A1 school limited, right? So it's the same thing over and over and over and again. So we can see that that's in Oraki. And as we go down the columns, you can see that here's Abbotsford School. It's a primary school, and that is in Dunedin. Okay. So again, it'll be replicated down for all of the entries for Abbotsford School. Okay. So it automatically found which columns to map on, to join on. So for example, in this case, it found that it was joining by school. Sometimes you might need to specify which column you want. So for example, if we say by equals school, then it will join by school only. And you can put multiple columns in there if you want. That's particularly useful if your column names don't match. So say I had one variable, so in the clean data set maybe it was called school, but in the schools data set maybe it was called name or something. So I'd say by school equals name, so that it knew how to match them up. Okay, so now we can use the all data set to summarize the number of students across the school level variables. So we could see how many students are there in each regional council. So we could take all of our data and we could group it by regional council, and we could summarize the number of students. So there you see you've got 283,000 kids in Auckland, across all schools in Auckland. Okay, and where I am at the moment in Manawatu, Whanganui, there are 41,000 students. Okay, how many girls and boys are in school with a religious affiliation? So we're going to have to figure out which column has religious affiliation information. So I think that's just the affiliation column. It might be the affiliation type. Let's have a look. Let's see what's in the affiliation column. So what I'm going to do to investigate that is I'm going to take my all data set and I'm just going to count the affiliation column. Okay, so the affiliation column here are look to be sort of affiliation types, don't they? So some are Muslim, some are Montessori, some are Methodist, some are Jewish, some are Baptist, Anglican, and so on. So the information that I want might be in here. So for instance, we've got non-applicable here, but it's sort of unclear. So I think we perhaps need the affiliation type column. Let's see what's in that. Ah, there we go. Perfect. So we can filter the affiliation type equals religious affiliation. Notice that I'm copying and pasting here. I'm selecting it, copying it, using Control-C or Command-C, just so I don't make a typo. Affiliation is one of those words that I'll probably stuff it up. Right, so there's all our rows with a religious affiliation, and then we want to know how many girls and boys there are, so we want to group by gender and summarize the total number of students. Okay, so we've got 57,000 girls and 55,000 boys. Okay, and the last one, produce a chart to compare the ethnic makeup of secondary schools in Decile 10 versus those in Decile 1, excluding international fee paid students. Okie dokie. Right, so we're going to take our data, we're going to exclude international fee paying students, so remember that that is in our ethnic group column. So we want to say ethnic group is not equal to international fee paying. Okay, so we have reduced our data set there, so that's looking good. We want only Decile 10 and Decile 1 secondary schools, so we want another filter for the sector. It's going to be secondary. Okay, and we want just Decile 1 and 10. So remember, we can use the percent in here. There we go. So if we go across, we should only have Decile 1 and 10. So Decile 10, and if we could keep going down, there'll probably be some Decile 1 at some point. There we go, Decile 1. Okay, and we want to produce a chart comparing the ethnic makeup. So that's all of the secondary schools. So now we want to group by our decile and our ethnic group and summarize the total number of students, right? Because we want the number of students in Decile 1 of each ethnic group and the number of students in Decile 2 of each ethnic group. Perfect. And now we can chart this, right? So let's throw that into ggplot. And we're going to map our ethnic group to the x-axis. Our y-axis is going to be our total. And we'll perhaps facet wrap by our decile. So there we go. Here's the Decile 1 and here's the Decile 10. So you can immediately see that there is a quite a stark difference, right? So you remember the Decile 1 schools were those where kids come from a community that tends to have lower levels of wealth in general, whereas Decile 10 tends to come from communities that are wealthy. So we can see that the ethnic makeup of these two groups of students is very different, right? So those that come from less wealthy areas have an overrepresentation of Māori and Pacific students, whereas those that come from very wealthy areas have an overrepresentation of Asian and European students in comparison, right? And so this, of course, is repeated all over New Zealand, and that there is these equity issues. Okay. Now, I think it's the last thing we're going to look at is on tidying some real data. So we're going to look at a data set from the Ministry of Health on immunisation data. So this is not going to be COVID. There's lots of, obviously, COVID immunisation, vaccination data available. I've been doing daily summaries. See my Twitter if you're interested. So this is looking instead at immunisation data. So if we have a look at this website here, we're just going to click on it and go to a browser. And I'll bring that over here so that you can see. Okay, so this is the national immunisation data on kids. So there's various milestone ages, and then there's a bunch of, then there's essentially the percentage that are immunised. Okay, so there's lots of vaccinations that you get when you're a kid. You get one usually as soon as you're born, or at least there's one jab when you're born. But there are then specific milestones before which you should have had a certain immunisations. So there's immunisations for mumps, measles and rubella, and so on and so forth, right? There's a whole heap of different immunisations that we give to kids in order to avoid kids getting lots of preventable diseases, right? And so we're going to look at actual data from the Ministry of Health. So we're going to look at, I think it's this one here, the July to September. So I'm just going to click on that and open it with my version of Excel, which is not quite Excel, but you get the idea. And so this is the data that they supply. So there's a breakdown by ethnicity, and there's also a breakdown by social deprivation, which is sort of similar to the decile thing. And so you can see that we have various milestones here. We've got the 6-month milestone, the 8-month milestone, and so on, right down here, which is, unfortunately, we have a year and a month mixing together, but that's okay. And then we've got the DHB, so District Health Board. So there's 20 district health boards in the country, so that's these rows here, which are then repeated down. And then for each district health board, we have the number of kids that are eligible at that particular milestone. So this is across all milestones. We have the number that are fully immunised. Oh, sorry, this is 6 months. We have the number that are fully immunised, and then we have the percentage, right? So presumably this percentage column is just that number divided by that one times 100, right? It's not actually computed in Excel. It's raw numbers, so why this is an Excel file I don't know, but anyway. We've got this colouring that doesn't matter other than to break it up. We've got more counts here, more fully immunised counts here, and more percentages and so on and so forth all the way across. Sometimes you'll see that things are missing, so we've got NS here. NS, somewhere there'll be a note as to what NS means, somewhere in the sheet, probably down the bottom. Let's have a look. NS, data not shown to protect privacy. There's less than 10 people in the group. Okay. We've also got some dashes. Did I see some dashes there? Yes. We've also got some dashes. Perhaps that means no data at all. Who knows? Okay. And so what we see is this data is very much not designed to be read in using a computer, right? We've got a row at the start, so our headings aren't even at the start, our column headings. We've got a row at the start of essentially junk. I mean, for the computer, it's junk. It's just information on dates and stuff like that, which would have been nice in a column, but there we go. We then got 2 rows summarising the, telling us what the columns are, which is kind of useless. So we've got this row here. It's all wide, so it's all designed to be human readable, thus the colours and stuff, not machine readable. We've also got a total row, right? That presumably is just the sum of these ones. So if I add those ones up, I presumably get that number there. I don't know if I do or not. So that's an extra row that the computer doesn't need, right? Because the computer can add it up itself. We've also got this row here, which is obviously the total of this number plus this number and so on and so forth. So there's a lot of junk in this, which for a computer is annoying, right? Unfortunately, if we want to be able to do stuff with this data, so for example, produce charts, we're going to have to get it into the computer. So this is not a nice way for the Ministry of Health to distribute data that they want other people to use. This is fine if what they're wanting to do is give it to a manager so the manager can just eyeball the numbers or something. That's fine. But for anything else, it's not useful at all. You'll find that this is typical, although the Ministry of Health is very good with the COVID data. So the COVID data is long-form data. It can generally be read into the computer without too much hassle. Okay, so let's read this into R. So yes, lots and lots of problems with the data all summarized here. So we're going to read this into R. Now this particular code block could be a little bit touch and go, depending on your computer, because we're doing lots of things that computers don't like to do. We're downloading a file from the internet, saving it in the location that you should have your markdown file. So if I have a look at the files here, I've just downloaded this file here. I'm then running Excel sheets, so that should read in the sheets and tell me that I've got 2 sheets. deprivation and ethnicity, so I know what to put in the sheet argument for read Excel. I'm then reading the data in with Excel and taking a look at it. So the glimpse command tells us something about it. And you can see here that I've got 160 rows and 20 columns. That sounds about right. And these are the column headings, which you'll see are all just nothing. So essentially our data is basically junk. So what we're going to do to try and improve this is we're going to skip the initial few rows, with the skip argument. Okay, so now here we have this data here. I should actually have the Excel sheet in there, shouldn't I? So I think I'm reading the ethnicity sheet. Let's see. Yes, it is a bit different. I think we're going to use total, so I think this will probably come out to be the same anyway. So now we're getting somewhere. We see some actual data. We've got a proper heading here. Do we? No, we don't. This actually means which milestone it is. So this top row here is actually our all milestones row. Right? Let me get it back up in Excel so that you can have a look at it. So let's. Where have I got it? Saved. Okay, so that's this row here. Is the one that this row here is what, because we skipped the first three, so this row here has been used as our headings, which is okay because this is actually junk anyway. We don't want it. So we're not going to be able to pull out the actual headings here very easily without also getting junk rows. So we're just going to assign the names ourselves. Okay. So here we are creating the columns that we want and we're renaming them. So we're just grabbing out column 1, column 2, column 3, column 4 and column 5. All right, 1, 2, 3, 4, 5. And we're renaming them as the milestone, the DHB, District Health Board, and the number eligible, the number immunised, and the proportion. Okay, and so now we have a cleanish data frame. So our next step will be to filter stuff out. Okay, so if we have a look at some of this, we'll see we have some things we don't want. So for example, if we count the milestone, let's check that, and then we can see we have all of this stuff down the bottom here, which obviously we don't want, but otherwise things are okay. What about if we count the DHB? If we count the DHB, this is looking okay, although we've got national total. That's not a DHB, that's a total, so that's junk. And we've also got NA, that's junk. So we're going to do some filtering. So notice that when I counted the milestone, we didn't have all milestone coverage. I wonder if that's because I was using the other sheet. Anyway, that first thing isn't needed. So let's filter that out. And now we can count the DHB. We can see we've got 20 DHBs, each with 7 observations, so that's nice. And then if we count the milestone, we've got 7 milestones, each with 20 observations. So now we've actually got everything we want. Okay. We've got all of the 20 DHBs have 7 observations, and all of the 7 milestones have 20 DHB observations. So the data is now clean. Okay, so this isn't actually too bad. Depending on which dataset you download from the Ministry of Health's website, so if we go flick back and have a look there, we've got all of them going back to, a fairly long time ago, 2008. They changed the format over time, right? So you might end up with a more fun time than we just had today. But this is sort of the typical thing that you get with data from other people. Okay, data from other people is designed for other people. It's not necessarily designed for a computer. Okay, so often there's a bit of playing around. There's also a slight subtle thing that's happened here that I didn't notice when I first ran it. But what's happened here is when we filtered by DHB not equal to national total, then it actually eliminated the rows where the DHB was missing as well. So when we did the count by DHB up here, right, we had 22 different DHBs. After we filter out the national total, we've got 20. So somehow this is filtering national total and something else. And what the extra thing that it's filtering is NA. And that's because NA does not satisfy this, it will return NA, right, to DHB not equal national total. If DHB is NA, then that will return NA not true, right, that argument, because we don't know if NA is equal to national total or not, right, because it's missing. So it's also filtered out those where the DHB is missing. So for more readable code, I really should have not is.NA_DHB and DHB not equal to national total. That would be even cleaner, at least because then I know what's happening. Get the same answer, but it's more readable for me. Okay, so now that we have this data, what we notice is that, so if we just have a look at it again, so spit it out, then you'll notice that the eligible column is not numbers. The immunized column is numbers, hooray. The proportion column is numbers because it's double, which is short for double precision real numbers. But the eligible number is a character. And presumably that's because there's something in here that is not a number at some point. I don't know if we're eventually going to find it. Possibly not. It might just be that something was in there that isn't a number, and now we have to, but we filtered it out in our process. Okay, so now we're going to convert that to numeric, and then we'll have our clean data set. Okay. Next, we could just check that the proportion column is correct. Okay, because of course that should just be the immunized column divided by the eligible column. So what we're going to do is we're going to compute that. So we're going to compute a new column prop check, and as you can see that these are very essentially the same. Now because they're decimals, comparing them with equals might be not very useful, because they might not be exactly equal depending on how it was saved in the Excel spreadsheet. Okay, so what happens is that the numbers that you can represent in a computer take up a lot of space, 64 bits in the computer, or 128 depending on your, how you've got your floating point arithmetic set up. But when you write that out to disk, so you write that out to a file, say an Excel file, it may be doing a bit of rounding, because it may be converting it to a character string or something. I don't know what happens in an Excel file. Who knows, right? If you were writing to CSV, it would have rounded at some point, because it's not going to write all, 27 decimal places or whatever. It's going to round. So when we compare those two numbers, they're not going to be exactly the same according to the computer. They're going to be something different. So when I do the check, what I do is I subtract one from the other. I then compute the absolute value of that, which just basically converts it to a positive if it's negative, right? And then I check whether it's bigger than some very small number. So I'm using 10 to the minus 6. That's what the e to the minus 6 means, 10 to the minus 6. So 1 times 10 to the minus 6. So this will return any rows where the prop check is not equal to proportion, or at least not close enough to the proportion such that the number is small. I guess we could make this really, really tiny to see what happens. Yeah, so if I make that number too small, then you can see that even though to our eyes these numbers are the same, to the computer they're not the same to 16 decimal places. Okay, and so that's what's happened, is that as it's been written out to the Excel file, there's been some rounding happen. Or perhaps, when it was copied and pasted into Excel maybe. Okay. So that's what that syntax is there for. Okay, so the goal now is to produce this plot here. Again, this might be something that that works oddly for you. So you'll notice that I've changed the path here. I actually downloaded that, so it used to have an HTTPS link here, a link off my website. It didn't work on this computer, I think because the proxy's not set up or something. Anyway, it should work for you, but if it doesn't, just click on the link so you can see it. So for example, here it is here. There's the graphic there. So I just copied and pasted the original link that was there into here so that you can have a look at it. So we want to reproduce this chart. So what we notice by looking at the chart is we have the Y is the DHB and the X is the percentage. And then we've got some panels. So we're facet wrapping by the milestone. So that's the main thing I notice. There's also some detail. So we've got the colours that are different depending on whether they've met the 90% criteria. So we're supposed DHBs are supposed to be vaccinating 90% or immunising 90% of children at each milestone, but you can see that all of them are failing at 6 months, and most of them are failing at most of the other months. 12 months is the one that they do best at. Okay, all of them are failing at 54 months. The other thing I notice is that I only have up to 54 months here. I don't have 5 years. Okay, so I've got a vertical line here at 90%. So we're going to see if we can make this chart. Right. So we're going to start really, really simply by just getting the structure of the chart, and then we'll try and refine it. Okay. Right. So we've got lots of hints here to help us, which is useful. Now, the first thing I notice is that the 5-year... So to start, all I'm going to do is I'm going to do a plot so that I get something out of it. So I'm going to use my immunisation clean dataset. And I'm just going to do a column plot where the Y is the DHB, the X is the proportion, and then I'm going to wrap by the milestone. So that'll sort of get an initial plot that I can then mess with. Okay, so already I'm sort of close, right, to what I want. But there's a number of things that I can see are a problem. The most obvious is that I've got 5 years in here, and there's no 5 years in here, so I've got to filter that out first. So let's do our filtering. And then we'll pipe that into ggplot instead. Okay. Don't supply the data anymore. Right. Now things are starting to look kind of the same, right? What else? So we notice that the order here is not the same. So the order here is 6 months, 8 months, 12 months, 18 months, 24 months, 54 months, whereas the order here is not the same. So we need to reorder things. So let's try reordering that. Notice that there's a command, some hint here. The factor relevel command is useful for redefining the order of a factor variable. So we're going to mutate our existing milestone variable, and we're going to use factor relevel. We're going to take in our current milestone variable. We're going to look for the help on that. So either a function or character levels. Any levels will not mention will be left in their existing order after the explicitly mentioned variables. Right, so what we want first is we want our 6th and 8th month variables first, and then everything else we want the same, right? So we want to start with 6 months and 8 months, and then 12 months, 18 months, 24 months, and 54 months will follow. So we should just be able to say 6 months and 8 months, and then everything else will follow. Let's check. Yes. Awesome. That was easier than I thought. Okay. So now we've got the panels right. The other thing I notice is that the order here is wrong. Okay, we've got them in reverse order. Okay, so we've got Auckland to Whanganui, and here we've got Auckland to Whanganui the other way around. So we need to reverse that, and again we've got a help. So we can add in another mutate here. The DHB is equal to factor reverse DHB. There we go, that's better. Perfect, we're really getting close now to that chart. Now we can focus on, we've got a colouring here, don't we? The line is at 90%, the goal for each of these milestones. The bars are coloured based on whether the proportion has reached or surpassed the 90% goal. So to colour the bars, we're going to need another variable here as to whether it's reached the goal or not. And the goal is reached if the proportion is bigger than 90%. So we're going to add a new variable, so another mutate, which is going to be goal reached, is going to be if the proportion is greater than or equal to 0.9, 90%. And then we're going to fill by the goal reached. There we go. Nice. That looks the same, other than colours and stuff, right? What else is different? Anything else different? Labelling's a bit different. We don't have a DHB down here because it's kind of obvious they're DHBs. We've got percentage scale here and a percent immunised label here versus proportion. We don't have the guide, the colour guide, and we've got the lines. Okay, so let's perhaps take care of the labels. Okay, so we don't want a Y label, so we're going to set that to null to get rid of it. The X label we want to be percent immunised. Okay, now we've got to convert these numbers into percentages. Now the easiest way to do that is to change the scale. So we wanted to change the scale of the x-axis. It's a continuous scale, and we're wanting to change the labels on it to be label percent. So if you have a look in the lecture slides, you'll find a similar sort of thing happening for one of the examples, I think, from memory. Otherwise, we would just Google, right? How to change the scale to be, let's have a look. How to change scale to be percent ggplot. Okay, there we go. So slightly differently, there might be a different one. Okay, so there's some code for doing the same thing. Okay, we're doing a slightly different one. I don't know if this will work. Let's try it. We want X, obviously. Let's try that instead. See if this works. Yeah, so that works as well. Okay. I tend to use scales label percent, but the other one works as well. Okay, perfect. We want the colors, so again we're going to be altering the scale of the fill. We're going to do it manually, and we're going to just change them to, so we want our pink and grey. Nice. That looks very, very similar. The bars are slightly transparent with alpha equals 0.9. That's a nice hint. So we do see that we can see through them very slightly there. Let's add that. That's why these look a bit darker, I guess. oh, whoops, we're going to put that to our geom col, aren't we? That's looking very similar now. We want to turn the guide off. So let's look at how we can turn the guide off. Turn guide off, or turn legend off ggplot. How to remove a legend. Blah 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 blah. Oh, I didn't know that this worked. Let's try it and see if it works. Don't know if it will or not. Legend position equals none. Let's see if that works. Ah, it does. There we go. I didn't know that. The other way to turn it off is you can use guides. So you can use guides and you could just go, we want the fill guide equals none. That's the other way to do it. That's so this is specific to turn just one guide off. Sometimes you want some guides but not all of them. And the last thing is that we notice that it's themed differently, right? So we have the grey background because we're using theme grey, which is the default. This uses theme minimal. So we're going to add on theme minimal. And there we go. Essentially the same chart. Okay. So when you're reproducing a chart, the steps really are to get something up first, right? So you'll notice the very first thing I did was just ggplot, geom col, set up the y, set up the x, done, right? Set up the faceting. And then I modified it from there. Then I took care of the things bit by bit to move the plot closer and closer to something that we want to achieve. Okay. This is something that I always do, even when I'm developing a plot. If I'm creating a chart to show someone else, then I iterate on it a number of times. I don't just, write the chart like I've been doing in here. Unfortunately, there's a fire alarm. I'm going to stop it here because we're at the end anyway.